All right, guys, so standard 4 is graphing rational functions. You did this in Algebra 2. Some of you may have done it with a calculator. You will not be doing it with a calculator today, okay? So a couple of steps to go through here. You always want to make sure your numerator and denominator are factored. That way it's easier to see if anything cancels out and creates a whole, or it's easier to see what your x and y intercepts are sometimes when it's factored. Then your vertical asymptotes, you find that based on your denominator being 0. And then the horizontal asymptotes. Do you guys remember the whole top heavy, bottom heavy, and balanced? Like, are those familiar terms to you? Some say no. Okay, so what I'm talking about with that is the degree of your numerator and denominator. If the degree of the denominator is bigger, we consider that bottom heavy, and you always have a horizontal asymptote of y equals 0. If they're balanced, meaning the degree in the numerator and denominator are the same, all you have to do is divide your leading coefficients. And then if the degree of the numerator is greater, that's considered top heavy, and that's when we end up with a slant asymptote. And we'll actually go through division to find that, so that's why you have to learn long and synthetic division before we can graph. Then holes in your graph, that happens if any factor cancels out of both the numerator and denominator. You can cross out step 5. I'm not looking for you to make a gigantic table of values and plug in numerous points. Not looking for perfection on these graphs. I'm looking for the general shape following the asymptotes with a couple of key points there. Okay, so you're not going to plug in tons and tons of points, just enough so that you know what your graph looks like. Okay, so let's try some. Let me get rid of this. I did change some equations a little bit for you, so don't work ahead of me today, okay? And I'm actually going to change the third one too. So, number 1, we can look at as it is, though. All right, so we've got this 2x plus 4 over x minus 2. I could factor a 2 out of the numerator, but is that really going to do anything for me? No, so we're just going to look at it as it is. The first thing I'm going to try to find is my vertical asymptote. Okay, remember, vertical asymptote, that is where the denominator equals 0. So, what would make this denominator 0? 2. If you write this, write it as an equation. Tell me that it's when x equals 2. Okay. Then on your graph, I'm going to just sketch that asymptote right now. X equals 2. All right. Horizontal asymptote. Horizontal, okay. This is the whole top heavy, bottom heavy, or balanced. So what is the degree of our numerator? 1. What is the degree of the denominator? 1. So what do you think that means? Balanced, and we divide the coefficients. So all I'm looking at are these two. So what is 2 divided by 1? 2. So y equals 2 is your horizontal asymptote. So go ahead and sketch that guy. Okay. We didn't have any factors that canceled out, did we? Okay, so we don't have any holes. So let's look at our x and y intercept. So actually, I'm going to write balanced next to this guy. All right, x-intercept. An x-intercept is it's an ordered pair. It's a point, And it means I'm on the x-axis, so my y value has to be 0. Okay, I have this fraction then that I am setting equal to 0. But how is a fraction equal to 0? Like, which part of it actually matters if I want it to equal 0? The top part, because if it's 0 divided by anything, it's going to be 0. So to find the x-intercept, all I really have to do is set the numerator equal to 0. Okay, just so that's your little reminder over here. This is what we're doing. So what does x end up being? -2. So the point -2, 0 is your x-intercept. All right, y-intercept. If I'm on the y-axis, I know my x value must be 0. So what you're doing this time is just plug 0 in for x. Okay. So 0 in the numerator would give me a 4, 0 in the denominator would give me a -2. So what is my y-intercept? -2, is that number? Jumbled with the answers, all right. So 0, -2, so I can plot that. Okay, we almost have enough stuff to draw our entire graph at this point. The asymptotes, remember, are going to guide the shape of your graph. So a vertical asymptote, can I ever cross a vertical asymptote? No. Okay, that value does not exist in your graph. What about a horizontal asymptote? Can I cross that? You can cross that. No, mind blowing. In the middle of your graph, somewhere around here, not a big deal at all if you cross a horizontal asymptote. It tells you what the ends of your graph are doing. That's the whole purpose of a horizontal asymptote. So I know as I go out towards -infinity, my graph is going to approach this 2 value. And as I come this way, it's going to approach the 2. So having these 2 dots here, do you guys know what the shape looks like based on the asymptote? Yeah, it's like this little curve. It's going to follow both asymptotes. So I can draw that part of it in. Okay. We need a little bit more going on with our graph. Some of you probably understand it enough to tell me where the next part is going, and some of you are going to want to plug in points. That's fine. Either way works. Anybody have a guess which of the other areas the graph is going to go in? The top right is going to be diagonal from it, yes. If you're not sure, just check a point. Like, let's plug in, I don't know, 4 won't be too bad. I'm picking something past that asymptote, okay? So if I plug a 4 in, what do I get in the numerator? 12 over 2, right? So that's really 6. So the 0.46. You guys see how that's in that little section? And then the asymptote's going to guide you. If you want more points, go for it. I'm fine with you just going, yep, there's my general shape. As long as you have the general shape right and the intercept right, I'm not going to nitpick over other points. Okay? All right, questions on the first one? So we'll do number 2. All right, number 2 here. So rewrite it for me. I changed the equation to x plus 2 over x squared plus 5x plus 6. Go ahead and try that. All right, this is one that we can factor. So the numerator is fine as x plus 2. What does the denominator factor into? X plus 2, x plus 3. So what's going to happen on this one? They're going to cancel out, and that creates a hole. Good. So guys, down here, I'm going to rewrite all that is left, which is 1 over x plus 3. Okay, so now we're going to start piecing together all the parts of our graph. So vertical asymptote. What is my vertical asymptote? Okay, and what equals -3? X, good. Vertical asymptote is always x equals. So I'll sketch that. Okay, horizontal asymptote. Is this top heavy, bottom heavy, or balanced? Bottom heavy. So what does that make my horizontal asymptote? 0, and y equals 0. Good. Okay, we said we have a hole this time, right? So let's think about where our hole is going to be. I need the coordinates, like the x and y of the hole. So we crossed out the factor x plus 2. So what do you think the x of the hole is going to be? 2 or -2? -2, yep. Okay, how can I find the y part of that? What'd you say? Okay, and should I plug it into like the original, or should I plug it into this reduced one? Reduce. If you plug it into the original, you will get 0 divided by 0, which is not what you need to figure out the y coordinates. But if you plug it in here, what is 1 over -2 plus 3? 1. It's -2 plus 3 would be 1. So you need to go to the coordinate -2, 1 and draw a hole. Okay. All right, we got to think about x-intercepts and y-intercepts. All right, x-intercept. Remember from what we did before, that's where the numerator equals 0. Work with the reduced one. Can the numerator equal 0? The numerator is 1. Is that ever going to be 0? No. Okay, so there is no x-intercept. All right, let's think about our y-intercept. That's where you plug 0 in for x. What do I get? This is 1/3, yes. All right, so 0, 1/3. Again, it's just somewhere in here. I'm not going to be picky. I'm not going to look at your graph and say, oh, you plotted 0, 1/2 instead of 0, 1/3. Okay, get it in between the right two numbers, and that's all that matters. Okay, do I have enough to draw the right section of my graph?
Yes.
Yeah, I know it's going to follow these asymptotes. Do we have a guess where the other part is going to go? Yeah, what do you think? Bottom left, we think down there? I agree. Let's test just one point, just to make sure everybody sees it. So left of -3, maybe I plug in -4. What do I get when I plug in -4? 1 over -4 plus 3. What does that get? -1. Okay, so yes, -4, -1. I'm down here. I know the shape looks like this. Any thoughts as to, yeah, go ahead. When it might not just be across from each other like that? What might make it not do that? Yeah. Okay, a slant asymptote, it'll look a little different. Sometimes they still end up across from each other, but just across from a slant asymptote. What else? Okay, 2 vertical asymptotes, you get all sorts of weird stuff going on. What if there's only 1 vertical asymptote? Is there a time when it might not alternate like that? Think about when you graph polynomials. Was there anything that made it like go from negative and then go back down negative? What caused a bounce? A squared. Yeah, maybe if your vertical asymptote is squared. Okay, it's just if you see multiplicity, you want to think about what's happening a little more. Okay. All right. Let me give you a different one for the 3rd one here. I know that that looks like what we want to do, but I'm going to change it a little. Let's make it. We'll just go 3. Actually, -3 over x plus 2 squared. So I want you guys to try to graph that one. Walk around and see how you're doing. And you can talk to each other. Guys, there's only 1 vertical asymptote. Okay.
So I didn't know that. Oh, God. Okay. See, that's why I was like, I don't take the opposite. There's no way. Yeah.
All right, some of you have moved on to the fourth one, so let's make sure we go through the third one. A lot of you got it. A lot of you made the mistake I kind of thought you might make. So don't do that. Don't make the mistakes I think you're going to make. All right. You're good with your vertical asymptote here. Most of you said, okay, x equals -2. Got it. Horizontal asymptote. Most of you saw that's bottom heavy, y equals 0. All right, we're okay with that? X-intercept? None, because there's no way that my numerator can equal 0. Okay. Y-intercept? When I plug 0 in for x, I get -3/4. That is down here. Guys, that is enough to draw this side of it. Okay? Several of you said, okay, I know what this looks like then. It must be up here. No.
Wrong.
What else is that? Yeah, wrong. What else is happening? Do you guys see this square? Yeah, so that changes things. So if you tested a point, if I checked, let's say, -3, I'd have -3 over -1 squared, which is really just -3. So -3, -3. It's down here. Remember, that multiplicity messes with things. It's like a bounce on your other graph. It was below my horizontal asymptote. It is still below my horizontal asymptote in the next section. Does that make sense? Okay. All right. Try number 4. We definitely, actually let's do this together because what's different about this one? That's a slant asymptote, yes. Okay, so let's figure out our factoring first just so we can look at all of that. So we've got x plus 4 and x minus 1 over x plus 1. Okay. Does anything cancel? No, so I don't have a hole in this one. I do have a vertical asymptote. Where is it going to be? Good, x equals -1, so I've got that guy to start with. Okay, I actually have a slant asymptote this time because it is top heavy. The way you find a slant asymptote is to actually do the division of your rational expression here. Do you want to do long or synthetic? Synthetic. Synthetic will work, right? Okay, so let me come down here where I can still... So I'm going to put a -1 out here. 1, 3, -4. All right, guys, I'm going to start the division. 1, -1, 2. You can actually stop there. You can finish it if that makes you feel better. But we do not care about the remainder when we are finding a slant asymptote. It doesn't matter. You're never going to graph a remainder. It's basically insignificant as to what the asymptote looks like. So all I care about is this x plus 2. That is the equation of my slant asymptote. Y equals x plus 2. How do I graph the line y equals x plus 2? What do you think, Anna? You just do it? You go like this? Where does it start? Yeah, at +2. And then my slope is up 1 over 1, right? So I'm just going to do a little dashed line going up 1 over 1 every time. So that is my slant asymptote. Can you guys see it okay? It's not that bad, right? Okay. Next up, x-intercepts. I actually have 2 of them this time. How do I find x-intercepts? Okay, and really it's just the numerator equaling 0. That's what I care about. So what are the two places where the numerator could equal 0? -4 and +1. So those are my two x-intercepts, -4, 0, and 1, 0. Do you guys notice that I'm always writing these as ordered pairs? I'm doing that because I want you to write them as ordered pairs, okay? That's how you should note them. So -4, 0, I'll put a dot, and 1, 0, I'm going to put a dot. And then let's find our y-intercept. So if x is 0, all the stuff with x's is gone. What is left in as my answer? -4, good. We actually have enough right now to draw the shape, okay? You can plug in more points if it makes you feel better, but I don't really want to plug in more points.
Do we follow the slant?
Yes, you follow the slant. So it's going to go like that. And then this one will go like that. Okay? So is a slant asymptote that much more difficult? Not really, no. It's just another thing you have to look at. Okay. In your packet, there's some practice graphing rational functions. I want you to do a couple of these right now. Let's do, oh, well, there we go. Let's do number 1. And then let's try 8. I know we're going to run out of time before we get through too many of these. So let's do 5 and 8. 1, 5, and 8. No, fire drill is not this period today. It's actually at the beginning of 6th today.
Yes.
Ooh, okay.
That's good.
You want to miss out on some 6th today?
Yeah.
You're just really happy that you're not missing math today, right? Yes. Okay, that's good. All right, guys, try 1, 5, and 8. I know we only have 10 minutes left, so let's do these 3. I want you to work on them. Walking around. If you're stuck on anything, let me know. Oh, and guys, I'll pass back your last 2 assessments while you were working. Yes. Good.
Yeah. Okay. Okay. Yeah, that was fine. Oh wait, no.
But it's good that you remember what you're doing.
Zero divided by. Oh, I bet. Okay. We're in class.
You guys, you gave me some very entertaining drawings, so we'll, I don't know, I'll pick the best of the best. Okay,
No. Yeah.
I know, I was like, oh, so sad. I almost
There's a better one. There's a good
yeah.
Yeah, so like there.
Or that calendar thing you gave me. It's, they're all listed on there when they're reviewing. Okay. Is that just a tired?
Yeah.
Okay. Full week business.
So like, okay, yeah, so, but, okay, yeah. Someone of like five,
Okay.
-115.
I like it.
Oh, wait, I think it's a plan.
I'll take Y.
Yeah.
Take Y. It's just. Dude, I don't know what I did, I know. Yes, guys, you didn't put f of x equals. It did take you to a 3. I know. Guys, but it's because the notation matters. Okay, and you'll remember now. Okay, let me try to get a couple of these up here for you. Alright guys, did you get number 1? Yeah? Good one. What was tricky about 5? Everything. Guys, it has 2 vertical asymptotes. And does that make you uncomfortable that 0, 0 is actually a point on your graph? You can be on the horizontal asymptote. I know you don't like it, but you can be.
Zero, that's why you're zero. Because,
Guys, I don't think we actually have time to finish this with me giving you your homework, so we'll come back to this as part of your warm-up next class. On homework standard 4 that's in your packet, so just turn the page one more time. You only have to do the odds, but you also need to do this free response number 4. This type of question is definitely important to your understanding of the standard 4 concept, okay? So guys, next class, when I see you on Thursday, you do have your assessment on standard 4 and your first retake on standard 2, I believe. But then there's no new notes. We'll do, it says fake quiz. It's basically like a review of standards 1 through 4 to make sure you're retaining that knowledge and we're clearing up any issues you have. Okay? All right, guys. Make sure you're tracking your scores on your little standard tracker, keeping an idea of what you are struggling with, what you are not struggling with.